Now, let us discuss about a C program to simulate best fit contiguous memory allocation technique. We know that we will use best fit in contiguous memory allocation techniques such as MFT and MVT. So there, in order to store a process in the main memory, we will use best fit. So best fit means allocate the smallest hole that is big enough. So first let us see an example and then we will see the program, and after that we will see the execution also. So let us see the output first. So enter number of blocks. Here the block can also be called as partition or whole or fragment also. So 4 blocks are given. Enter number of processes. 3 processes are given. So the sizes of the blocks are 5, 8, 4, 10 and the sizes of the processes are 1, 4, 7. Here our target is we have to store these processes in the corresponding blocks of the main memory. So block can also be called as partition or fragment or whole. The size of the first process is 1. So here we are using best fit. Best fit means allocate the smallest hole that is big enough. So out of 5, 8, 4, 10, what is the smallest number? 4. We can store 1 in 4. So that's why process 1 is stored in block 3. If you see here, process number 1, what is the size of the process number 1? What is the size? 1. And it is stored in which block? This is third block, block 3. The size of the third block is 4. And what is the internal fragmentation? Here the internal fragmentation is, here the block size is 4, whereas the size of the process is 1. So 4 minus 1 means 3. So 3 is the internal fragmentation in that block. Likewise, if you take the second process, the size is 4. So what is the smallest number here? Allocate the smallest hole that is big enough. 4. But block 3 is already occupied. So block 1, block 2, block 4 are free. So out of 5, 8, 10, which is the smaller number? 5. So we have to store second process in block 1. So store second process in, what is the size of the second process? 4 in first block. What is the size of the first block? 5. What is the internal fragmentation here? Block size is 5, whereas the process size is 4. So 5 minus 4 means 1. Here we can use best fit algorithm in both MFT as well as MVT. In MFT we will get internal fragmentation, whereas in MVT we don't get internal fragmentation. Assumes that it is MFT technique, so we will have internal fragmentation. There is no problem. Next, the third process, the size is 5, but here the third block and first block are occupied. So third one and first one are occupied. So out of here the third process size is 7. So we can store 7 KB of the process in 8 KB of the block as well as 10 KB of the block. So which is the smallest number? 8 is the smallest number. So we can store process 3 in second block. So what is the internal fragmentation? 1 is the internal fragmentation. So for this we have to write the program. So let us see the program first and then we will see the execution. So here we have stdio.h and maximum number of processes are 10. So max is nothing but a symbolic constant. So max value is 25. So maximum we can enter 25 processes. Next, the variables are NB. So NB stands for number of blocks. So printf enter number of blocks, scanf %d comma ampersand NB. In this example, totally we have 4 blocks are there. Okay. Next, NP. NP specifies number of processes. So printf enter number of processes, scanf %d comma ampersand NP. Here totally we have 3 processes are there. Next, this B of max. So this B specifies the size of the block. Here if we specify NB as 4, then totally we can read 4 block sizes. So B of max So maximum we can read, maximum we can have 25, but out of 25 we have given only 4 blocks. So let us see here, printf enter the size of the blocks. So for I equal to 1, I less than or equal to NB. Suppose if we start from 0, then we can proceed up to I less than NB. So it is our choice. So here the initial value is 1. So we have to continue up to less than or equal to. So printf block percentage d comma I. So first we will get block 1, next to block 2, block 3, block 4 likewise. So scan of percentage d comma ampersand b of I. So this b is nothing but, this b array is nothing but size of the block. Next one is p of max. So this p specifies size of the process. Size of the process. Size of the process. If you see here, printf enter the size of the processes. Here I will share this program in the comments. In the first comment I will share the program. I will ping that comment. So please go through the comment for the program. So for I equal to 1, so total number of processes are NP. I less than or equal to NP I plus plus. So printf percentage process percentage d comma I. So first we will get 1, process 2, process 3 likewise. So scan of percentage d comma ampersand p of I. Okay. So next one is frag. So this frag is for internal fragmentation. Here I and j are loop variables. Okay. For repetition we are using those two variables. Here we are using temp and lowest for calculating the smallest hole. Smallest hole. If we have 3 holes, then we need to find out the smallest hole. So for that purpose we are using temp, and here the initial value of the lowest is some largest whole number. Okay. Here we have taken 5, 8, 4, 10 as the block numbers. So we can take greater than 10. It is our choice. Okay. So we can take 10, 20, 30, 40, 50, greater than 10 value. Okay. So here I am taking lowest as 10,000. Next here we have taken BF of max and FF of max, 2 variables. These 2 variables are of type int but static. Here the major difference between here this variable, if you declare a variable, by default this variable will become local variable. This int will become local variable, whereas this is static variable. The major difference between local variable and static variable is, by default the static variable default initial value is 0. Here initially I want to store 0 in BF of 0, BF of 1, BF of 2, BF of 3. So likewise in FF of 0, FF of 1, FF of 2, FF of 3 also I want to store 0. So that's why we are declaring it as static variable. Here BF of 0, it specifies that that block is free. Whereas if that block is occupied, then we will set with 1. Okay. So initially the value is 0. If the block is occupied, then we will change that value from 0 to 1. Okay. So that's why we are using static. So the initial values of all the array elements are zeros. Now let us focus on the logic. For I is equal to 1, I less than or equal to NP. So here the outermost for loop is for process repetition, whereas innermost for loop is for block repetition. For j equal to 1, j less than or equal to NP, j plus plus. Okay. Next, if BF of j not equal to 1, what is BF? So this BF is nothing but static array. Static array. If you see here, this BF and FF is nothing but static array. So static array means initially what are the default initial values. Here we didn't perform any initialization. So that's why the default initial values are 0. So initially BF of 0, BF of 1, all those contain 0. So BF of 0, initially what is the value? 0. So 0 is not equal to 1. Yes, condition is true. So now let us take a value. Let us take a value. Assumes that here we have a process. Let us trace with the help of an example. Yeah, here we are tracing. Yeah. Here we are tracing. So let us trace now. So here let us trace here. Let us assume that let us take the first process. Let the size of the first process is 30 KB. let we have three blocks or three fragments where the first block size is 50, second block size is 60, third block size is 45. Third block size is 45. So here what is the size of the process? The size of the process is 30, whereas block sizes are 50, 60, 30, 45. So here we can store process 1 in all the three blocks. In all the three blocks. Why? Because 30 is less than 50, less than 60 and less than 45. So in which block we have to store? We have to store in the smallest block. Out of 50, 60 and 45, what is the smallest value? The smallest value is 45. So we have to store the process in third block. So let us see that logic. So temp is equal to B of j minus P of I. Here what is j? J is for block repetition. Here we have three blocks. So what is the formula for the temp now? Temp is equal to B of j. What is the initial value of j? 1. The initial values of I and j are 1 only. I for process, j for blocks. Here I am showing for first process. Okay. Temp is equal to B of j. So what is B of 1? 50. 50 minus, what is P of 1? 30. So 50 minus 30 means 20. So temp equal to 20. Next, what is the condition? If you observe here, what is the condition? If temp is greater than or equal to 0, here this if has only this if has only one condition. So that's why we didn't use any curly braces. If you want, we can use the curly brace here. Use the curly brace here. After this right curly brace, just we can close the curly brace. Okay. So now if temp greater than or equal to 0, yes, condition is true. What is temp value? 20 only. 20 is greater than or equal to 0. Okay. So we can, so now the body condition is true. So the body will be executed. If lowest is greater than or equal to temp, what is the initial value of the lowest? The initial value of the lowest is 10,000. 10,000 is greater than temp. 10,000 is greater than temp. Yes, condition is true. So what we have to do? F of 0 equal to F of 1 equal to 1. So F of 1 equal to 1. So that means we are storing the first P1 process in the first fragment. Okay. So next, lowest equal to temp. What is the next statement? Lowest equal to temp. So now lowest value will become temp value. What is the temp value? 20. So here always this lowest contains the smallest number. Lowest always contains the smallest number. Out of 10,020, which is the smallest number, 20 is the smallest number. Okay. So next what will happen? The body of the innermost for loop executed. Next j will become 1. Previously j value is 2. Now j value will become 2. So 2 is less than or equal to, this 2 is less than or equal to number of blocks. So how many blocks are there here? 3 blocks. Yes, condition is true. Next, if BF of j not equal to 1, initially BF of 1, 2, 3 all are 0 only. So BF of 2 is not equal to 1. Yes, condition is true. Initially it contains 0. BF of 1, 2, 0 contains 0 only. So condition is true. So what will happen now? Temp equal to B of j minus temp equal to B of j minus P of I. What is B of j? B of 2. Now j value is 2, I value is 1 only. B of 2 means 60. So 60 minus 30 means 30. So here what we are doing? We are finding the difference between the second block and the process. So now the difference is 60 minus 30, 30. Next, what is the condition? If lowest is greater than temp, what is lowest? 20. What is temp? 30. What is lowest? 20. What is temp? 30. So 20 greater than 30. Condition is false. So there is no need to change the lowest value. Why? Because between 20 and 30, which is the lowest value? So 20 is the lowest value only. So there is no need to change the value now. So f of 1 equal to 1 only. So that means now the first process is stored in first fragment only. So next what will happen? Body execution is over. So once again control goes to j plus plus. So now j will become 3. If BF of 3 not equal to 1, yes, condition is true. Why? Because initially all those values are 0. So temp equal to B of j minus P of I. So what is B of j now? B of 3. B of 3 means 45. So 45 minus, what is the process? That process is 30 only. In the first iteration, the value of I is 1 only. So 45 minus 30 means 15. So now what is temp value? 15. 15. So next condition, if lowest is greater than temp, what is lowest value? 20. Greater than 15. Yes, condition is true. Out of 20 and 15, which is the lowest value? 15 is the lowest value. So that body will be executed. What is the body? F of 1 equal to, what is the J value now? Now J value is 3. So that means we have to store the first process in the third fragment. FF of 1 equal to 3. So that 3 specifies that we are storing the first process in third fragment. Next, lowest equal to temp. Lowest equal to temp. So now this lowest value will become 15. So what is this lowest? This lowest is nothing but internal fragmentation value. Here what is the size of the process? 30. Whereas what is the smallest hole size? 45. So 45 minus 30 equal to 15. So that is nothing but lowest value. So likewise we are storing the first process. So likewise we can store second process, third process, fourth process also. So this is the logic. And after that what will happen is frag of I equal to, here this is j iteration. So this is nothing but end of the if, this right curly brace. Okay. Next, this right curly brace for end of if, this right curly brace is for end of the innermost for loop. Here the first iteration is over. After the first iteration, we got the first process. The first process can be stored in the third hole. So now what is the statement? Frag of I. In the first iteration, what is I value? 1. 1 equal to what is the lowest? 15. So 15 is the internal fragmentation. Next, B of FF of 1. BF of, this is the second static variable. So that means here we are using BF. So BF is a static variable. It is an array. Initially BF of 1, 2, 3, all the values are 0. But now here we are storing this first process in third block. So that's why we have to change the value from 0 to 1. So BF of FF of I. FF of I means FF of 1. What is FF of 1? It is already calculated. The value is 3. So BF of 3 equal to BF of 3 equal to 1. BF of 3 equal to 1. It specifies that the third fragment contains the process. Whereas BF of 1, BF of 2 is 0. It specifies that those fragments doesn't contain any process. Next, again, we have to change the lowest value. The lowest value is 10,000. So likewise, we have to compute for second process, third process also. So in this way, we can write the logic. Now let us see the displaying. So this is nothing but end of the outermost for loop, that is for I. So likewise we have to repeat for second process, third process also. Okay, if we observe here, so if BF of j not equal to 1, so initially 1, 2, 3 all are zeros only. Yes, condition is true. Next, temp equal to B of j minus P of I. So here we are computing the difference between the block and the process. So here that value should be greater than or equal to 0. That value should be positive value. If it is negative value, then there is no need to compute. Why? Because it has some size. Size means it is a positive number. If lowest is greater than temp, then we can say that it is the lowest number. So store temp in the lowest and store that j value in FF of I. So whenever the first iteration is over, then we have to store this one. Frag of I equal to lowest. Next, BF of F of I equal to 1. Likewise. Next, if we see the output, first here we are displaying the process number. For process number, I is the variable. And the second one is process size. For process size, P of I is the variable. Next one is block number. Block number. For the block number, we are using FF. So first process is stored in which block? Third block. So this is nothing but FF. FF of 1. FF of 1. So FF of I means that block number. Next, for the block size, before the FF of I, we have to write B. So B of FF of 1. So that is nothing but B of, what is FF of 1? 3. B of 3 is nothing but the size of the third block. Next one is internal fragmentation. So likewise we are displaying. So this is the condition for displaying the all the processes data. Now let us see the program execution. Let us see the program execution. Let us run the program. Let us run the program. Enter the number of blocks. So let the number of blocks are 4. Next, enter the number of processes, 3. Next one, enter the sizes of the blocks, 5. Next one is 8. Next one is 4. Next block size is, instead of 4, just I have given 41. Next sizes of the process, 147. So this is the output. Let us run the program one more time. So enter number of blocks. So 4 blocks. Enter number of processes, 3 processes. Next, block 1 size 5. Block 2 size 8. Block 3 size 4. Block 4 size 10. Next to process 1 size 1. Next to 4. Next to 7. So if you see here, so this is the output. So process number is 1, 2, 3. Next one is give one more /t so that you will get the output in the proper indentation. So process sizes are 147, whereas the block numbers are 312, whereas the block sizes are 458, whereas fragments are 311. So I will share the code in the first comment. Just go through the first comment for the corresponding code. Thank you.